we're going to do electrical circuits in series. Okay. Have a look at this electrical circuits. It's a electrical circuits connected in series. What does it mean in series? Is the current doesn't split up. Okay. Now let me show you another example. Okay, now look at this circuit. Okay, it has three resistors connected in series. Okay, so use the equation V equal to IR. Okay, I can find the current because the current doesn't change. It doesn't split up. Okay, so but the resistance is different. So what we need to do is we need to find the total resistance. Okay, so but in physics we don't call it the total resistance. We call it the equivalent resistance, which is on the screen, which is named RE, which is 600 ohms, just adding them up. Okay, so then do the calculation. Okay, we can find out the current. Okay, use V equal to IR, which is 0.002 amps or 2 milliamps. Okay, so after that, we can do some calculations. Now, don't be confused when I draw that. Okay, what I mean is I draw a voltage meter, okay, measuring the voltage across resistor 1. Okay, so since we know the current, okay, we can use the equation V equal to IR. This time, because I only want to find the current, the voltage across resistor 1, so what I do is the resistor will be just 100. We don't use the equivalent resistance. Okay, do the math, 2 volts, so we know the voltage across resistor 1 will be 2 volts. Okay, so we do the same thing with we do the same thing with the second resistor. Again, the current doesn't change because the current doesn't split up. Okay. What I draw here is only a voltage meter, a voltmeter, which is means it's an electrical device designed for measuring the voltage across a resistance. Okay, so if we do all the math, we find out here we are able to find out the voltage across each resistor. Okay. Okay, now if you look at this carefully, okay, so the voltage across each resistors ended up to 12 volt, which is our power supply. Okay, so power supply. Okay, so and yes, this is what's happening in a circuits connect in series. Okay, so say the total resistance is called equivalent resistance, RE, okay, which is just adding all them up. Okay. By the way, this formula here is only works for electrical circuits connected in series. Okay, so there are different types. There are two different types, and well, the calculation, the formula we use for equivalent resistance are different. Okay, then for for series electrical circuit, we can also know the total voltage, okay, will be the same as the voltage of the power supply. Okay, so I just write down total voltage. It will be the same. It must be the same. If in reality it will be a little bit different because of the power loss. Because for example, okay, the wire is not 100% efficient. The wire may use some energy, may use some voltage. It's not 100% efficient. But in theory, okay, they should be the same. Okay? So the voltage, the total voltage should be the same as the voltage across R1 plus the voltage across R2 plus the voltage across R3. Okay. Now I show you a real life application of it. Okay. Now, now have a look at this example. Okay. I have a power supply of 240 watt. Okay, voltage, same as what you get at your home. Okay. Now, I have an electrical device, okay, some special device. It will only operate at 120 watt. Okay. So here is what we can do. Okay. So the idea is we cannot connect them together. Okay. I have 240 volts as power supply. If I connect them together, okay, directly, it will burn the device up. The device will receive too many power, too many energy, and it will doesn't work. And sometimes, in most of cases, it will damage the device. Okay, so what I normally do is, well, what we can do is, we can put a resistance beside it. Okay, assume the device has a 2k ohm resistance. Okay, so what we can do, I put another 2k is 2000 ohms. I put another 2000 ohms resistor next to it and I connect them in series. Okay. In this way, if we do the calculation, okay, I should have 120 volts on across the resistors and the device. Okay, so the equivalent resistance will be, well, let's do the math. Okay. It can be, yep, we find out the current. The current doesn't change because it doesn't split. Okay. Now, if I do the math, I find out the voltage across the resistors and device should be 120 volt. Oh. So the device works. Okay.